Hello everyone. Now we will discuss wear strength of bevel gears. Before going to that wear strength, already you can see the beam strength value of the bevel gear, because that beam strength or wear strength depends upon formative spur gear. That's perpendicular to the tooth element at the larger end. That's why you can first of all see the formative spur gear and virtual number of teeth. Then you can learn about wear strength. That's because the contact between the two meshing teeth of the straight bevel gears is line contact, and which is similar to the spur gear. That's why the wear strength of the bevel gear is considered to equivalent to the formative spur gear, and then we have used that value for the find out the value of wear strength. We have used that value wear strength value formula of formative spur gear for the find out the value of wear strength of bevel gear, and this is the original formula of wear strength for the of spur gear is used for find out the wear strength of the bevel gear. This is the SW is equals to B into Q into D dash P into K, that's a pinion, and K, that's the wear strength formula. Sometimes that's a G value, and pinion or gear. This is the wear strength formula of spur gear, and that's here we can use the find out the value of bevel gear. This is the face width, Q ratio, P circle diameter, K material constant. That already part we have covered. How we can find out that value in bevel gear? See here, the P circle diameter of the formative pinion gear dp dash is equals to 2 times RB, because that RB we have considered the value for central, for that central value, or we can consider the face width of that bevel gear, the 1/3 portion or 3/4 of the face width is effective in bevel gear. That's why we have considered that's a central value or central force resultant force acting on that bevel gear. That all part covered in force analysis, and that's why here we can put up that value in equation, and we can got 19.1 equation in Bhandari. That already part covered in terminologies and virtual number of teeth, and dp dash is equals to dp divided by cos gamma. This is the modified formula for the P circle diameter for the formative spur gear, and dp capital dp suffix p, capital D suffix p, which is a P circle diameter for the larger end of the tooth, and that value dp put up here in SW original equation, previous equation. In that equation you can put up the value of dp value, P circle diameter, and here we can put up that value dp dash p, and then SW is equals to bq dp k divided by cos gamma. This is the formula, and here we can assume one of the factor is there 0.75, because the in bevel gear only 1/3 means 3/4 of the face width is effective. That's why 3/4 means 1 upon 0.75. that's a term we have considered here, 0.75, and multiply that factor, because only 3/4 face width is effective in bevel gear and meshing with another pinion or gear. That's why we consider only 3/4 of the face width of that gear. That's why SWP pitting failure is only for the 3/4 of value. That's why here we can modify that formula, that C formula again, 0.75 BQ dp K divided by cos gamma, and this is the final equation of the wear strength for the bevel gear. And in that Q is equals to Q ratio factor, also again it's a 2 times ZG dash divided by ZG dash plus ZP dash, that formula, and again put up that value ZP for cos for the gamma in terms of pitch angle for the pinion, and again one of the formula gear pitch angle, and put up those values in that Q equation, and finally you can got that equation Q is equals to 2 times ZG divided by ZG plus ZP tan gamma. These formulas are you can remember, and K also material constant you can remember. No option for that formulas. Sigma c square sin alpha plus cos alpha in bracket 1 upon EP plus 1 upon EG divided by 1.4. These formulas are different for helical and bevel gear. You can remember those formulas, and K is equals to 0.16 into BHN divided by 100 bracket raised to 2. This is the K value in terms of Brinell hardness number, and these values you can find out, and finally you can check the wear strength value and P effective value if the wear strength value is greater than P effective, the design is safe and it does not go to the pitting failure. And suppose your P effective value is greater than SW, it goes to the failure, and then you can check the factor of safety. This is the procedure to solving the problems, and these formulas are required for numerical. You can remember those formulas, okay. And also same of the effective load on the gear, just like as you already seen spur gear and helical gear effective load. You can check those formulas, same formulas, torque formula, PT formula, P effective formula, CSPT. One of the method is a velocity form factor, another dynamic equation, that's a Buckham's equation. First method is a preliminary equation method, CSPT divided by CV, and another method is a dynamic equation. CV is here we can consider only that equation. CV is equals to 6 divided by 6 plus V and 5.6 divided by 5.6 plus in square root B. These are the cut teeth and generated teeth. In problem they are mentioning cut teeth and generated teeth. At that time you can specify those formulas, you can remember those formulas. CS service factor, velocity factor also you can consider there. And the another method, the secondary method, that's a dynamic equation for the checking the design is safe or not. That's a PD is equals to 21 times V CEBT plus PT divided by 21 V small v, that's a pitch velocity, pitch line velocity, plus in square root CEBT plus PT. This is the formula for dynamic equation, Buckham's equation for bevel gear. You can use those formulas. And for the bevel, in that bevel gear usually made of steel, and deformation factor C is equals to, in that deformation factor is equals to 11,400 Newton per mm square. This is the standard value for steel material, and you can put up that value and find out the equation. And then that PD value put up in P effective, CSPT plus PD, and you can check the for the failure SB and SW, and you can calculate the factor of safety, you can calculate the SB, you can calculate the P effective, and compare those formulas, calculate factor of safety, given factor of safety, wear strength value. These all values you can check and decide the design is safe or not. And also another factor is error factor. That error is depends upon class wise and module. You can class 1, class 2 and class 3, and depends upon module you can select. Otherwise in numerical they are provided that value, that table in Bhandari 19.1 table also you can check that values for the preparation or solving the problems for the errors. This is the basic P effective load formulas are required for the solving the problems. You can check the formulas, you can remember those formulas and solve the bevel gear problems. Okay, if any query ask me. Okay, thank you very much.